in the question they have given that the block A and of having the mass m and block B having the same mass m are moving on the inclined plane of inclinations theta 1 and theta 2 respectively. And they say that the block the coefficient of friction between the block A and the plane is given by mu 1, whereas the friction, the inclined plane on which the block B is moving, it is frictionless, means there is no frictional force acting on the block B. And they not only that, they have also said that the pulley is also frictionless pulley, which does not provide any kind of friction. It means that. So moving to the question, which of the following statements are true? So they are asking us to see whether which of the following statements are true. So when I come to the options, they are asking us that what is the condition for the block A to just start moving up. So in order to get those conditions, the block A will just start moving up. That will depend on the values of the theta 1 and theta 2 and mu coefficient of friction between the block A and this inclined plane. So moving further, when you analyze the whole scenario and the diagram, you will find that as a block A is kept on the inclined plane having the inclination theta 1, then the weight which is acting vertically downwards, mg is resolved into the perpendicular components mg sin theta 1 directed along the downwards direction of the inclined plane, and mg cos theta 1 which is perpendicular to the contact surface of contact. Okay. So here, as the block A, as we know that the block A will not show any kind of motion in vertical direction. So the block A is in vertical equilibrium. We can say that the N1 will be equals to mg cos theta 1. So, not only that, they say that the coefficient of friction between the block A and the inclined plane is mu 1. That means that the inclined plane will provide frictional force to the block A. When the block A is just start to move up, then the frictional force will be produced and it will be directed downwards, because we know that frictional force is directed opposite in the direction of motion. It always directed in such a direction, it will be produced in such a direction to oppose the motion. So our block A may start moving up. So let us find the conditions. So we know that the frictional force acting on the block A will be given as mu into n, where mu is the coefficient of friction between the block A and the plane, that is mu 1, and n is the normal force acting on the block A, which is n1, and we know that n1 value is mg cos theta 1. So we obtained the frictional force acting on the block A. Now moving further, we can see that as the block B is lying on the frictionless plane, so there will be no frictional force generated over here. That means that the block B is also having the weight directed downwards vertically. When we divide the weight into two perpendicular components, that is mg sin theta 2 and mg cos theta 2, the mg sin theta 2 will be directed downwards to the plane. So we can see that this force which is directed downwards to the inclined plane is generating the tension in this string. So that tension T is generated in this string, which will be transmitted over the whole string. So here we can see that on the block A, the forces acting are the tension force, which is directed upwards, which tries to move the block upward direction, and the mg sin theta 1 and the frictional force are acting downwards direction in order to oppose the motion. So the block A will just start moving when this upward force will be equals to the sum of the two downward forces. That is, the block A will just start its motion whenever the tension in the string is greater than or equals to the mg sin theta 1 plus F. So I am equating that. So mg sin theta 1 plus F. Okay, here F is a frictional force acting on the block A, which we already found. When I substitute T, okay. One more thing here, the tension in the string was generated due to this downward component of acting on the block B. That is, T is equals to mg sin theta 2. Let us assume. Okay, we are saying that we are equating both, because we know that the reason for generation of tension in this string is mg sin theta 2. So we are equating that we are assuming that T is equals to mg sin theta 2 is equals to mg sin theta 1 plus F. When I substitute here, mg sin theta 2 is equals to mg sin theta 1 plus f we know that mu 1 mg cos theta 1. So when I cancel mg on both sides, I get that sin theta 2 is equals to sin theta 1 plus mu cos theta 1. So when I solve further, I get that mu is equals to sin theta 2 minus sin theta 1 by cos theta 1. Okay. So when I see that, so I can say that the necessary condition for the block A to just start its motion upwards, means it's just ready to move, start moving upwards, is mu is equals to sin theta 2 minus sin theta 1 by cos theta 1. So whenever the mu value is equals to this, then the block A will just start moving up. Okay. Of course, it will be ready to start its motion towards upward direction. So our option B is true, and option A says that our option B is true, and option A says that A will never move up the plane. It is wrong because there are the chances that A may move up the plane, and that chance is if our tension generated in the string is greater than the sum of the two forces, then A will move up, and if our T value tension is equals to the sum of the two forces, then A will just start moving up. It means it is just to perform its motion towards upward direction when this tension value is equals to the sum of the two forces. So there are the possibility that A may move up. So our option A is wrong. Coming to option C says that for A to move up the plane, theta 2 must be always greater than theta 1. Let us verify this. We know that whatever the coefficient of friction, it is always greater than 0. It may be less than 1 or it may be greater than 1. That is a separate case. But we know that the basic condition is that the coefficient of friction will be always greater than 0. So based on this condition, we can say that as the theta 1 is the angle in this is the one of the angle in this triangle, and we know that all angles in a triangle will be acute or it may be right angle, but it will not be obtuse angle. That is, theta 1 will be belongs to the first quadrant. Okay, quadrant number 1. So as the theta 1 belongs to quadrant first quadrant, our cos theta will be always positive, no doubt. So denominator is always positive. So for the mu to be greater than 0, our sin theta 2 should be always greater than sin theta 1. So this is possible when our theta 2 is greater than theta 1. It means that whenever the theta 2 is greater than theta 1, then A will just A will show its motion upwards. If not, A will not show its motion up in the upward direction. Our option C is also true. Moving to option D says that B will always slide down with a constant speed. So when we observe B, it's not necessary because when we observe B, the downward component of force acting on the B is mg sin theta 2, and the upward force which is acting on the B is tension in the string. It is fetching it upwards. Okay. So whenever the tension in the string is equals to this downward force, then in that time the net force on the B will be equals to 0. So in that case, as there is net force, the acceleration is 0. In that case, the block B will move with a uniform velocity, that is constant speed in the downward direction. But the same is not possible always. If sometimes there may be the possibility that mg sin theta 2 may be greater than t. Then in that case, if the mg sin theta 2 is greater than t, then in that case the block will accelerate downwards. Then in that case, the block B will not be sliding with a constant speed. So our option D is not necessarily true. It may slide with the constant speed or may not. So overall option B and C are true.